Everyone, I just wanted to provide some quick guidance about the ES verification tool that I've been developing. So I'll share my screen. The intent of this tool is to be used for ES verification, but more broadly, it's just intended to access data associated with ecological sites. Um, so it allows you to look at what data exists, the distribution of the site, and then there's some options to kind of set a criteria for what fields you want to be populated and evaluate whether those actually are populated. So you can access the application at this URL. And then there are some instructions in the top left. The first step is to enter an ecological site ID into section A. So I'll enter a site that's in the Sierra Nevada foothills where I work. Step 2, click fetch data and wait for load. So I'll hit fetch data here. You can see down in the bottom right, it's fetching the data. It usually takes 5 to 10 seconds. You get kind of a summary description of that fetching process at the top of the screen. So it says some data failed to load, veg transect summary, no data associated with this ecological site ID. So there's no veg transect summary data for this ecological site. So we'll move on to step 3, choose required fields in section B. So in section B, there are a few different fields that you can populate. They loosely correspond to NASA's tables. In some cases, they kind of aggregate kind of some similar tables into one. So it's not an exact match of NASA's tables, but it avoids having some additional tables that only have one or two fields in them. So site, veg plot, plot plant inventory, vegetation transect, and vegetation transect summary. If you open one of these, you'll see that there are a number of fields and they either have a check mark next to them or they do not. If there's a check mark next to them, then they're being considered required fields. And you'll see that this is already populated, so some have check marks and some don't. This is loosely populated based on a medium intensity verification, and that's based on the guidance that the working group put together. You will notice that in some areas there are kind of groupings. So this is geomorphic component, and you can have geomorphic component hills, mountains, terrace, and flats. Um, and so for these sections, and I'll show it in the plot plant inventory because it makes a little bit more sense there. So for abundance, we have species canopy cover class, species canopy cover percent, species trace amount flag, and AK stratum cover class percent. So if you have any of those populated, that will satisfy the criteria of abundance. If there's one of those fields that you don't want to consider as satisfying the requirement of abundance, you can uncheck that. And so now one of these three will need to be populated to satisfy the requirement of abundance. And we'll look at some of the tables that this produces later on. But I think that should suffice as an understanding of how these grouped categories differ from some of the just elements that only have one element within them. Okay, so that covers step 3 here. So then step 4, choose filtering criteria if desired. So we'll come down to section C. You can see that there is a date field, so site observation from, and by default, it covers from 1912 to 2025. So that's going to hit everything. This date here is going to be today's date. And so if you want to hit all your sites, then just keep that default range and that should hit everything. Then you can also filter for certain state IDs or community phase IDs, or if you want to look at one particular user site ID, you can put it in here. And to start off with, I'll just bring everything up and then we can look at some examples of why you might filter your results down. So that would bring us to step 5, click filter and map data. So I'll click filter and map data. And this brings up in the EcoSite tab here some summary information about your ecological site. And so I see here 108 sites with vegetation plots are correlated to this site. A minimum of 20 are required. When it specifies as the minimum, that does take into consideration the national instruction for verification projects, saying that if you have fewer than 4 components, then you don't need the full 20 observations. So I believe it's 5 observations per component. So if you had 1 component, you would only need 5 observations. And so this will take that into consideration. If you only had 1 component correlated, it would just say a minimum of 5 are required. Uh, so that's that. And the next one here, the following states and phases from the EDIT STM are not represented in the site data, and it lists 1.2 and 2.1. And so this is pulling data from EDIT, and it's looking at the state and transition model, and it's saying that you don't have any site data, this would be pulling from the site observation table where you can populate state and phase. It's saying it's not finding any sites or site observations that have a state and phase of 1.2 or 2.1, and those do exist in the EDIT STM. So for ES verification, you would want and would be required to have those represented in your data. Then we have a little table here. This is just some kind of overview, summary information about whether you have sites that are passing the criteria that you've defined. So we can see here, the metrics are the number of sites and the number of sites passing. And then we can see for the site table, we have 108 sites, 0 sites are passing. For the veg plot table, 77 sites and 0 are passing. For plot plant inventory, we have 77 sites and 37 are passing, so on. So that gives you kind of a black and white interpretation of, are they passing or are they not passing? And below that, we have some histograms, which give you a little bit more detail about kind of the distribution and completeness of that data. And when I say completeness, that's referring to you've defined required fields in section B and what percent of those are actually populated. So let's say you put, you have 20 different required fields in the site table and you only have 10, then it would be a 50% completeness. So looking here, we'll look at histogram of site completeness. And you can see down on the bottom, this is the percent completeness and the record count on the y-axis. And so you can see you have 0 sites that are 100% complete. We have a little group here, like maybe 4 or something, that are in the 90% complete range. And then we've got a whole group that are between 50, 60, and 70% complete. And then another group down here in kind of the 20 and 30% completeness. You can see the same for veg plot and the other required tables as well. So then we have the map tab here. The map tab gives an idea of the distribution of the site. And so you can see there are 2 different colors and shapes here. One are these rectangles in kind of a grayish color. And that's a generalized map unit. And so it's not showing the actual geometry of the map units because it just takes a lot more time to load. But this is giving the kind of a generalized going from, like the X and Y min, creating kind of just a generalized polygon. And really the intent there is to look at the distribution of the site. Do you have observations of this ecological site across the extent of the site? So that's really the purpose there, as opposed to kind of looking at like the spatial or spectral or topographic characteristics within these polygons. So you can, if you find useful, change kind of the base map here to satellite imagery, or you can change it to topography. But just keep in mind that obviously those map units are not actually the shape of those map units. You can also click on these to get some information. So you can see what the site is, what the ecological site is. It should be, the ecological site that you queried for. So that's not too informative, but then it also has the state and phase assigned. All right, so we'll move on. The next section is we have these 5 tables: site, veg plot, plot plan inventory, veg transect, and veg transect summary. So these all work basically the same way. When you click on them, it shows all of the different fields that were mentioned in section B, and the intent of this is to show whether you have all the necessary fields completed. So when you scroll across, you see that there are these red background colors, and that's saying that this is a required field, but it's not populated. So that's a missing field there. The first column we have is passing or not passing. So an X is not passing and a check would be passing. Then you have the percent completeness, and these tables here are interactive, so you can sort. A realistic situation might be, let's look at what sites are close to passing. So this is 87% complete. We've got a few that are 87% complete, and you might target those and say, all right, let's get those over the threshold to being complete. It mentions here the number of columns that are required. So you define that 30 columns are required, and there are 4 columns that are missing. So then you can scroll across and see what the required columns are that are missing. So we've got 1 there. And then over here, we've got head on text, date, author, and entry. So that'd be 2, 3, 4. So those are the 4 missing columns. So you could populate those, and to conceptually understand this app overall, this is pulling from NASAS through web reports. And so as soon as you populate those fields and upload that to the database and rerun this, it will show the updated data that you have. So, if you populated the geom slope seg, then this would no longer be missing. So the same thing applies for these other tables. One thing that I will mention is for some of these grouped fields. So for things like abundance that I mentioned that are grouped, you only need one thing populated, right? And so if we come over here, or sorry, this is in plot plant inventory. So in plot plant inventory, we'll come over and we'll look at, so we have species canopy cover percent, species canopy cover class, species trace amount flag, and then I'm realizing AK stratum cover class percent is over here, which it should be moved over. So I'll move that column over so that it's grouped with these. But basically what you're seeing is this is not considering that species canopy cover percent has a missing field because one of these other columns is populated. And actually 2 of them are populated. The species trace amount flag is 0, and the AK stratum cover class percent has data. So if any one of those fields is populated, then they will all be considered complete. And if they're all missing, then that only counts as 1 column missing, right? So if you didn't have anything in these 4 columns that are related to abundance, then when you came over here, that would only count as 1 missing column because it's really just abundance is missing. If you populate any one of those, it would satisfy the criteria. So I think that does it for kind of understanding how to use these tables. Now I'll show the use of some of the filtering capabilities. So let's say I collected some new data for this ecological site this year, and I just want to look at that. So I'll put in a date. So I'll put in January 1st of 2025, and I'll filter my data. I'll come back to the EcoSite tab, and we'll see that I collected 4 sites this year, and you can see the distribution of the data. So these are looking a bit more complete, at least for site and veg plot and plot plan inventory. Um, you can then look at the map and see where were those observations for this year. You can click on them, see they have state and phase information. Um, and then this just breaks it down. These are only going to report those 4 sites that I collected this year. Um, and then you can, so the idea of the dates there is basically, for 2025, or since the verification project, I'm trying to hit, low or medium intensity observations. So you might have some different criteria that you're applying. For the more recent stuff, I'm trying to hit those guidelines that were established. But for some older stuff, if I'm looking from, old data up until the verification project started, I might reduce the criteria here, to whatever seems reasonable based on talking to your EDQS or regional ecologist, something like that. So you can kind of differentiate the different eras of data and apply different criteria for what might be satisfactory for a verification project or something else. And then these state and phase fields, they're pretty straightforward. Let's say, I think this is probably going to pull up the same data because I think these are all in state 1. But let me briefly pull up a different site. So let's see. Well, I think these are all in state 1 and phase 1. Yeah, they are. But anyways, you get the point. That's going to reduce the results to just things that are in that state or in that phase. Another functionality that I find helpful is, let's say you're in the site table and you're like, all right, I'm going to try to get these sites that are close to being complete. So I'm going to start with this site here, and I can take the user site ID and put it down in the user site ID and filter for that. And now all of my tables are going to be just related to that one ecological site ID. And I find that more useful, when you're on some of these tables that they have multiple rows per site, right? So for plot plant inventory, each of these rows is specific to each species. And so that allows you to more easily assess uh, the population for this one particular site. And so I can look through and see, there's maybe 10 species or so that are recorded here, and look through and make sure, did I get, a plant type group or some sort of strata or abundance information for each of those? Is there anything that's missing? So that's the overall idea. I do want to mention one thing, which I probably should have mentioned at the beginning, but the way that this application works is through web reports from NASA. So it's pulling data from NASA, and the key linkage there is sites being correlated to your ecological site. And that's done through the site ecological site history table. So it's looking at that site ecological site history correlation, the most recent correlation date, because you can have a history there of correlation. So it's pulling from the most recent correlation. And if it's correlated, if you have sites that are correlated in NASAS, it's going to pull that, and it's going to pull all the associated tables if they exist. So that's the overall idea. If you have any ideas or run into anything that's not working properly or anything like that, let me know and I'll take a look. So hopefully this is useful, and thanks for listening. Bye.